Okay, so we're gonna pick up from where we're at with this. I forgot to start the recording. We are using the common angle theorem and the common segment theorem as we go through these notes. The common angle theorem and common segment theorem. And we have actually talked about where these came from and done a couple of examples. So let's move on. Let's do a couple more examples. Go to problem number 7. Not 7, 5. Go to number 5. Everybody look at number 5. Number 5 says, draw a conclusion stating that two angles are congruent. State a postulate, definition, or theorem that supports your conclusion. Okay, so angle 7 is congruent to angle 9. Okay, so it's saying if these are congruent, draw a conclusion. Write down your conclusion.
Bless you.
Okay, let's see what we have. Raise your hand if you know the answer. All right, what you got, Nick?
Okay, so I have angle ABE is congruent to angle FBG using the common angle theorem.
Okay, look closely. ABE, isn't that the same thing as angle 7?
Yeah.
That's not what you wanted to say, is it?
Oh.
What did you want to say? Angle AB what?
Yeah.
ABF. Because you're actually adding in that angle 8 to get a larger angle, right?
Mm-hmm.
And you're adding in that same angle 8 to get a larger angle here, right?
Yes.
Okay, so the answer for this is angle ABF is congruent to angle
EBG? Or is that
EBG. And you could also call that angle GBE or angle FBA. And state the postulate or theorem we're using, this is called the common angle theorem, right? Alright, so that's kind of one thing we've been looking at today. Okay, so now I did want to throw in here that we're going to review a couple of ideas we haven't done in maybe 3 or 4 weeks, yes?
Are we gonna do all this on a separate sheet of paper?
You may write them wherever you'd like. I believe you can squeeze them in on this page, okay? Just like I just did, but like when I do number 7 just now, go ahead and go out to the margin if you want. And thank you for asking that question, okay? And you do want to probably do this in pencil so that you can clean up your diagram and mark on it every time you're doing it. So I just cleaned my diagram. Now I'm going to look at a few more. Number 7, angle EBC is supplementary to angle 1. Angle 2 is supplementary to angle 1. So we're looking at number 7. Okay. So angle EBC is supplementary to angle 1. EBC is this big angle right here, right? And it's saying it's supplementary to angle 1. And then angle 2 is supplementary to angle 1. Hudson, you know the answer?
Maybe.
Maybe. Tell me what you think.
Is it the AC and DG are parallel? If it's kind of like alternate interior. I know.
Well, you do have some alternate, kind of like alternate interior, but no, that's not what we're looking for. Jason, do you know?
Is it angle ABC is congruent to angle 2?
Good job. Can you tell me the theorem that tells us
Ooh,
this?
I don't know what it's called, but it's like supplements of the same angles, or of the, like, two angles are supplementary to the same one angle, then those two angles are congruent.
Very good. It's called the congruent supplement theorem. But when we were using it in proofs, which has been about 3 or 4 weeks, okay, we actually wrote it out so that you could get it in your brain, okay? But don't feel bad if you didn't remember, because most people are not remembering it. That's the point of us reviewing it, to kind of keep it active. So in this case, what we've determined is if they're supplementary to angle 1, and angle 1 is in with both of them, they have to be congruent. The theorem says 2 angles supplementary to the same angle are congruent. Alright, I wrote part of that with notation. The theorem actually says 2 angles supplementary to the same or congruent angles are congruent, okay? And it's also called the congruent supplement theorem, okay? So that's number 7. So kind of a review. All right, at this time, I would like you to omit problem number 9. Since this question did ask us to state 2 congruent angles there, we have not done the theorem that they're using there. We've done that another way that involves 2 steps. So I'm just going to omit that for now. Okay, let's go to number 10. We're doing some random things. Go to number 10. BF bisects angle EBG. See if you can come up with the answer. BF bisects angle EBG. Now, I go over this one because it's real important for you to see that this figure is not drawn to scale in any fashion, right? Does everybody see that? This figure is drawn in such a way to make you apply the rules without just looking at it and saying, hey, it looks like this, right? Okay. So what would be congruent because of number 10?
8 and
Angle 8 and angle 9, right?
9. Yeah.
Okay. What's the reason?
Definition
I don't-
of bisector.
Definition of what kind of bisector, husband?
Angle bisector.
Angle bisector. So you know we've used this, right? So this is just really practice of things that pop up in proofs. This is definition of angle bisector. Okay? Alright, how we doing? Doing okay? So we've looked at the segment addition. No, we've looked at the common segment theorem, the common angle theorem, and what you're going to find on the next page is that those things are going to come into play when we do proofs, okay? So real quickly, number 2 on the next page. Angle 4 is congruent to angle 1. That means angle BAE is congruent to what?
4, 1.
FA,
FAC.
C or D?
FAC or D?
C.
FAC.
Everybody agree?
C.
Okay, one more, number 4, before we do the proof. If DF is congruent to CE, if DF is congruent to CE, EF is congruent to what?
DC.
DC or CD, right? That one is using common segment theorem, right? So those are our new ideas that we were working with, okay? So those things, you can do the rest of those. Let's go on down and do proof number 7, okay? So proof number 7. Given NM is perpendicular to MQ, RQ is perpendicular to MQ, MN is congruent to QR, and MS is congruent to QP. we're gonna prove that NP is congruent to RS. Okay, so we're gonna make our first step all the given. Okay, so everybody write down all your given, we're gonna do a nice little proof. So number one, everybody write down all your given. Now, once you've written it all down, mark what you can on the diagram. I made a mistake. Let's put this. This should be a P. Okay, so there's all my given. Now, using that, somehow I have to prove that NP is congruent to RS. Okay, so my right angles are in there, the perpendicular marks. MN congruent to QR. MS is this little short piece congruent to QP. And somehow I'm trying to prove that these little yellow segment lengths are congruent, right? Okay, all right. Anybody know what to do?
Well,
Daniel, you live?
can you just, I wanna say that you can do side angle side.
Okay, if we did side angle side, we would be proving that triangles are congruent.
Well, if you
Yes.
prove they're congruent, can you say that NP equals SR or no?
Okay, so there's a good question. If you prove the triangle's congruent, would that make the yellow segments congruent?
I think so.
Yes,
Why?
because equal,
Third angle.
lateral,
Oh, that's side
yeah,
angle.
triangles are.
Because they're what
Oh,
now?
congruent. No, corresponding parts of congruent triangles are congruent.
Very good, that's why. Okay, so that's our whole proof, how we gotta go through the process. We're gonna get the triangles that look like they're overlapping, right? To be congruent. And once we prove them congruent, we can write down the proof statement, okay? So also remember that anytime we've done overlapping triangles, we generally sketch them outside the figure just so we can mark on them, right? So I'm doing a quick sketch. I'm marking the pieces I know. Okay? That's what I know so far. I don't really know anything else that I can mark on just those parts, right? Alright, what do I do now?
You can say that NP is congruent to SQ.
So MP is congruent to
SQ,
Y,
because of the
Oh, yeah, you have to.
common segment.
the common segment theorem. So that's that new theorem, so you can see this theorem at play in this proof, right? This is the common segment theorem. And then I'll actually go to my, up here and mark them with double marks, or 3 marks, since this is the third set of segments. Okay, have I got everything I need?
No.
What do I need?
You need to state that the triangles are congruent.
There's right triangles.
We're gonna have right angles, right? And then what?
That the triangles are congruent.
And then the right angles are congruent, because we're gonna use the right angles in our congruence, right?
Oh, you have to.
So remember, this was a double step process to go there, right? So because the lines are perpendicular, that means that angle M and angle Q are right angles, right? What's the reason?
Definitely.
Definition of perpendicular.
Definition of perpendicular. We've done this over and over again. This should be on your test, I think. Angle M is congruent then to angle Q, right? What's the reason?
Definition of right angles?
No.
It's not a definition, but it's a theorem that says.
Oh, all right angles are congruent.
All right angles are congruent, okay? So all right angles are congruent, okay? Now we've actually got the parts we need, right? Number 5, what's next?
Triangle.
Side angle,
and-
Side angle side. You can see it on the little purple triangles we drew, right? Okay, so triangle NMP is congruent to triangle RQS, remembering that the letter order must be in the right order. And then we can from that say that NP is congruent to RS. If we know the triangles are congruent, we know corresponding parts are congruent, right?
Is there a theorem or is it just corresponding parts of congruent?
It's actually CPC. Every other letter is C, okay? Parts are of the triangle, okay? It stands for corresponding parts of congruent triangles are congruent. Okay? Everybody comfortable?
Have we done that?
We did that.
Really?
We haven't done it a lot in the end of proofs, but we've done it in the beginning in the first couple of sections. Okay? Alright, you got it written down? Okay. So you think you could finish this up?
Miss Young, can you can you go to the first page?
Go to the first page. Yes?
The first page, it's saying that
Talk to me.
are 9, 10, 11, 12 all different or is it all together?
They're all separate questions.
So all what it's stating are different.
Yes, you're giving a conclusion of 2 segments for every one of them. Does that make sense?
Yeah.
Okay. All right.